If you don't perform knurling frequently, the calculations around it can get confusing. Hello everybody, Erez here from the Machining Doctor website. Stay tuned and let me show you everything you need to know about it.
These are the topics we will cover. What is knurling and what it is used for? The main types of knurling tools. And finally, the main topic of the video, knurling calculations. Let's start by defining what it is. Knurling is a manufacturing operation, performed on a lathe, that copies a pattern from a knurling wheel onto a round workpiece. Knurling is performed by the displacement of material, as the knurling wheel is pressed against the surface of a rotating workpiece. It is mainly used to increase the friction for easier human grip. A classic example is a micrometer knob. Or improve the connection of a metal part assembled into plastic, like in electronic connectors. In other cases, it is used simply for decorative purposes. There are two types of knurling technology: cutting and forming. In knurl cutting, the wheels are tilted and move along the axis of the workpiece, cutting instead of forming. This type of tool is more expensive, and its implementation is more complicated. Nonetheless, it is easier to control the diameter, smaller forces are exerted on the workpiece, and higher feeds can be used. This video will focus on forming knurling tools, which are the most commonly used, since they are cheaper and simpler to utilize. The knurling wheel is pressed onto the rotating workpiece, and displaces material, forming the pattern from the knurling wheel. The forces involved are high, leading to low feeds. However, the biggest challenge with this method is that the outer diameter is increasing, what we call material growth. The user needs to calculate the correct diameter to turn before knurling in order to achieve the desired final diameter. This diameter is nicknamed blank diameter and is designated as dB. Now, let's see how we estimate the required blank diameter and reduce trial and error. The material growth, G, is the difference between D, which is the final knurl diameter, and dB. Hence, dB equals D minus 2 times G. Since D is usually indicated on the drawing, what is left for us is to estimate G. We can do it with the material growth formula. Pitch in TPI, powered by minus 0.94 times 0.16. These values are valid only for straight knurls. If you have a diamond knurl, you should add 15%. The easier path is to use the knurling calculator on the Machining Doctor website, which will compute dB and G for you. I put the link to the calculator in the video description. However, our headache does not stop here. We also want to avoid incomplete teeth. The number of teeth that will be formed equals TPI times pi times the diameter. The outcome will always yield a non-integer number of teeth. At this point, we should round the result to the nearest integers and calculate the corresponding diameters. Always check that the diameter is within the allowed tolerance. Also, here, the knurling calculator comes to our rescue and shows you the blank diameter for the rounded number of teeth. I hope that knurling calculations are more clear now. If not, you can find all the formulas, with more in-depth explanations, on the Machining Doctor website. I will share the link in the video description.
So that's it for today. I hope you found the video informative and helpful. If you enjoyed it, please hit the like button. See you on the next one. Bye.